Okay, so here are Newton's three laws. So every body remains stationary or traveling at constant velocity unless acted upon by an external force. So that's just a fancy way of saying something, if it's not moving, it's not going to start moving unless you've got some kind of force applied to it. So if you have a book sitting on the table, it's not just going to suddenly start moving unless you push the book. Okay? Or something's going to be traveling at a constant velocity. Same thing, the velocity won't change of a car unless you press the accelerator or you press the brake. Okay? So that's a fancy way of saying those two things. So the second one then, force is proportional to acceleration. So whatever, if you just push your book a wee bit, your book will accelerate a wee bit. If you push your book a lot, it'll accelerate a lot. And from that we get an equation F equals ma, which is what we're going to look at now in a wee second. And the third one, for every action there's an equal and opposite reaction. So think about your weight, which is a force acting down on the seat that you're sitting on at the minute. That seat has to be acting up with the same force. Otherwise, either you'd fall through the chair, or if the force from the reaction on the chair was bigger than your weight, it would push you off the seat, which doesn't make sense. So these are three laws that are concerned with anything to do with motion. So we're going to concentrate on the second law, F equals ma. So a force 34 newtons causes a mass of m kilograms to accelerate at 1.6 meters per second squared. Find m. So we're using F equals ma. Our force is 34 newtons. Our mass is m kilograms and our acceleration is 1.6. So it's 34 divided by 1.6 gives us our mass, and our mass turns out to be 21.25, and that is kilograms. Okay, there's two parts to this question then. So find the force needed to accelerate a mass of 3 kilograms from 2 meters per second to 8 meters per second in 4 seconds. So this brings in F equals ma and the equations of motion that we've already looked at. So for part A then, we've got u is 3, v is 8, and t is 4. So we need to find the acceleration. So v equals u plus at. We have 8 equals 3 plus 4a. Take our 3 over and we have 5 equals 4a. So a is going to be 5 divided by 4, which is 1.25 meters per second squared. And then we're going to use F equals ma. So our mass is 3. Our acceleration we've worked out to be 1.25. So the force that we need is 3 times 1.25, which is 3.75 newtons. Part B then, find the distance travelled. So we'll have u is 3, v is 8, t is 4, a is 1.25. So we can use a couple of different equations of motion to find s. The easiest one is probably s equals a half upon u plus v times t. So we have a half times 11 times 4, and that gives us 22 meters. And our final one then, find the force needed to bring a body of mass 7 kilograms moving at 14 meters per second to rest in 3.5 seconds, and then find the distance covered. So again, this brings in equations of motion. So for part A, we've got the initial speed is 14, brings it to rest, that means the final speed v is 0 in a time of 3.5 seconds. So let's use v equals u plus at to find a. So we have 0 equals 14 plus 3.5 a. Bring that over, we'll get minus 3.5a equals 14. So a turns out to be 14 divided by minus 3.5, so it's minus 4. So that's what you would expect, a negative acceleration because it's slowing down. So then F equals ma. Our mass is 7. Our acceleration is -4. So we get a force of minus 28 newtons. Now the minus is just there because force is a vector, the same way as acceleration is a vector. So um, the sign is telling you what direction the force is moving in. Now the question just asked you what the force is. It didn't ask you what direction or anything like that. So therefore you can just say the force is 28 newtons. And part B, we've got U is 14, V is not, T is 3.5, A is -4, and we want to find the distance. Again, you can use a couple of different formulas. I'm going to use S equals a half upon U plus V times T. So that's 14 plus nothing times 3.5. So we have a half times 14 times 3.5, and that works out to be 24.5 meters.